now present grade 4 practice paper 5 part C, and we are close to the end of all practice papers, and part C is the penultimate video presentation for all grade 4 practice papers. Part C, like A and B, will contain the solution of 12 problems, and of course C means that we are in the third section of 12 problems. We will begin at problem number 25 and we will end at problem number 36. Here we have a portion of a calendar, and the calendar has August of 2015. So what we have on the screen right here is the month of August in 2015, and the problem is based on this month that we have represented here. On which day did August begin? Can you?
Saturday.
Okay, so Jerry is telling me already that it is on a Saturday that August began. The question is about August 2015, the month of the calendar that we have right there. So the month of the calendar that we have is August in 2015, and the questions are based on that month. Which day did August begin? Which day? The answer that we are looking for should tell us the day. The day, for example, on a Monday, Tuesday, Wednesday, or Friday. So the day on which August begins. A month begins on day 1. Let us first identify the first day of the month. The month begins on which day?
1.
Day 1. So let us find the day 1. It is right there. Day 1. It is easy to identify the day of the week that is associated with day 1. It is right below the heading. So day 1 is right below the heading that tells us the day of the week that we are in. It is right on Saturday. This tells us that the month began on Saturday. The correct answer is therefore option C. Which Thursday of the month was August 6th? Which Thursday of the month is August 6th? And this is a big question if it is just taken all by itself. However, the options that we have there will play the role like a guideline to tell us what our answer should be like. So the options that we have, the first, the second, the third, the fourth. Which Thursday? Is it the first, the second, the third Thursday, or the fourth Thursday of the month is August 6th? Thursday. The problem has to do with a particular Thursday. We are highlighting all of the Thursdays right there. And the Thursday that we are interested in is the Thursday that is on the 6th day. The Thursday in question is the 6th of the month. Which Thursday is the 6th day of the month? The days are in numerical order from top to bottom. So we have Thursday, and the Thursdays in the month are the 6th, the 13th, the 20th, the 27th. Those are all of the Thursdays that are in the month. So the one that is the 6th is the first, the 13th is the second, the 20th is the third, and the 27th is the fourth. The 6th day turns out to be the first Thursday. The correct answer is option
A.
Okay. Option A. If we traverse the month beginning on the first day, the 6th of August will be the first Thursday that we will encounter. So we are focusing on August 6th. And if we begin at the first day and we continue until we get to August 6th, let's see what will happen. Right. Is there any other Thursday that we encountered with before we got to the Thursday of the 6th?
No.
Right. There's no other Thursday that we encountered with before we got to Thursday of the 6th. And there's a reason for that we'll discuss in a few seconds. Therefore, the 6th has to be the first Thursday of the month. Additionally, any day of a month that is less than day 8 has to be in the first week of the month. Therefore, day 6, being a Thursday, has to be the first Thursday of the month. I hope you understand that, Jerry.
Yes, sir.
How many days are in 1 week?
7.
Right. Therefore, if we are talking about a particular day of a month, and that day is within the first week, and the first week will begin on day 1 and end on day
7.
Right. So as long as the days are from 1 to 7, then that day has to be in the first week of the month. Therefore, day 6th has to be, whichever day it is on the first such day in the month. So if it were a Friday, then it would have been the first Friday of the month because it is within the first week. So any day that falls from day 1 to 7, or we may say, as we said it before, any day that is less than day 8 in the first week of the month, and must be the what? First such day in that month. Before solving the problem, let us take a look at the hands of the clock and see how they are used in telling the time. The short hand is which hand, Jerry?
The hour hand.
Right, it is the hour hand. The numbers on the clock are hours. The hour hand tells the hour of the day that we are in. It is usually shorter than the minute hand. So the hour hand, which is which one? Which is the shorter and the stouter hand, tells us which hour of the day we are in. The longer hand is slimmer. So the longer hand is the slimmer hand, and it tells the minute of the hour that we are in. So the longer and slimmer hand is the minute hand. It is used to tell us what minute of the hour we are in. For the minute hand, the time between two consecutive numbers is equal to how many minutes, Jerry?
5.
5 minutes. So if the minute hand travels from 5 to 6, how many minutes that will be?
5.
And if it travels from 10 to 11, how many minutes that will be?
5.
Right. The time that it takes to go all the way around is 60 minutes, which are the number of minutes in an hour. So the hand will take 60 minutes to go all the way around the clock. As a matter of fact, we have how many numbers here, Jerry? All the way around, and we'll have how many hours?
2.
we will have 12 hours. If we are taking a look at the minute hand, between any 2 hours, how many minutes that will be?
5.
Do not forget that there are 12 hours all the way around. And we know that what? It takes 60 minutes to go all the way around because we have 12 hours and 5 minutes between each hour going by the minute hand. Therefore, we say what? 5 12s?
60.
That is how we will arrive at the 60 minutes that are in an hour. So there we will begin where the minutes of the hour begin. And the minute of the hour will begin at 12. And for every digit that we encounter with, that will be by the minute hand, 5 minutes. And we can count with the clock. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Also, the hour hand takes 12 hours to go all the way around the clock, while the minute hand takes only 1 hour. So the minute hand will take only 1 hour to go all the way around the clock. When the hour hand is between 2 hours, we may say that the time is after one of the hour and it will be before the other. Right here, the time is after 1 or before 2. We may even say that it is to 2. So our hand is not exactly pointing on 1. And it is not exactly pointing on 2. Therefore, what do we say? We say that that hour, or the time that is represented by the hour hand, is some time after the hour of 1. And it is also some time before the hour of 2. When the time is between 2 hours, the half in which the minute hand is located tell us whether to or after the hour is appropriate. What do we mean by the half? Well, we can consider that the clock may be divided into 2 halves. If the minute hand is in the first half, and as a matter of fact, the first half will go from 12 to 6, right? And if the minute hand is in that first half, going from 12 to 6, then after or past is more appropriate. So the time that we have is after 1. So after is more appropriate if the minute hand is located in the first half, which goes from 12 to 6. If the minute hand is in the second half, going from 6 to 12, then 2 or before is appropriate. This is before 2. So the time that we have here would be by the minute hand, if it is located in this half, is more appropriately read as before the hour or to the hour. If the minute hand is on 6, it is on half an hour or 30 minutes. We may say that it is half past the hour. It is also half before the hour, but we never usually say half before the hour. We always say half past the hour. Right. So this half is the first half going from 12 to 6. The minute hand is here, then past or after is appropriate. The minute hand is here on this side, to or before is appropriate. However, if the minute hand is exactly on 6, because it is half an hour or halfway around, we will say that it is half past the hour. Surely, because it is half past the hour, it is also half before the hour. But we do not usually tell the time and say half before or half to the hour. We always say half past the hour. We have shown how we may determine the number of minutes of a particular hour by counting the minutes in a clockwise direction. We did that earlier on when we were showing that we had 60 minutes in an hour. So we have shown how we may determine the number of minutes after a particular hour by counting the minutes in a clockwise direction. The minute hand is on the to or before side, so the time is some minutes to 9. In this event, we count the number of minutes in a counterclockwise, or it is also called anti-clockwise direction. So notice that the minute hand is in the second half, although we did not put the dividing lines there. We know that the first half goes from 12 to 6, and the second half goes from 6 to 12. So the minute hand being in the half that goes from 6 to 12 is indicating some time before the next hour. And the hour that it is leading to, the hour hand is leading to, is the hour of 9. Therefore, this is saying some minutes before 9 or some minutes to 9. We will begin our counting at 12, which is the position of 0 minute. So we'll begin right there. Do not forget that we are not taking a look at the number of minutes after the hour, which we will do in a clockwise direction, but we are looking at the number of minutes before or to the hour. Therefore, we will count in what kind of a direction, Jerry?
Anti-clockwise.
Right, anti-clockwise direction. The number of minutes before 9 may be determined. That is very quick. In the ancient days, we usually cause the minutes to tick slowly. The illustrative minutes, that is, when we are illustrating. But we have caused that to speed up a bit. So we have how many minutes? 5, 10, 15. 15, and we are at where the minute hand is. So we are counting the number of minutes till we get to the minute hand. There we go. The number of minutes before 9 may be determined. The time may therefore be read as 15 minutes to 9 or 15 minutes before 9. A period of 15 minutes is a quarter of an hour, and those periods may be indicated on the to or past side. So we have a quarter of an hour on that side, and we have a quarter of an hour on the other side. So the one on the past side is a quarter past, and the one on the to or before side is a quarter to. When the minute hand is pointing on 3, we say that it is a quarter past the hour, and when it is pointing on 9, we say that it is a quarter to the hour. The time indicated is therefore quarter to 9. The time that we have indicated. Let's take a few steps back. We have the minute hand pointing on 9, and the hour hand is between which 2 hours, Jerry?
8 and 9.
Right. Therefore, if the hour hand is between 8 and 9, we are sure that the time can either be read as after 8 or before 9. And we are saying that because the minute hand is on the side going from 6 to 12, then it is more appropriately read to or before. So we are saying that it is after 8 or before 9 but we are opting to use before or to 9 because the minute hand is on the 2 side of the clock. The time indicated is therefore 8:45. The 6th hour is halfway around the clock. When the minute hand is on 6, the time is half past the hour. Although it is also half to the other hour, we never say half to the hour. When the time is given digitally, the number representing the minutes is in reference to the time after the hour. So when we have a digital display of the time, the minutes are usually in reference to the time after the hour. And of course, what we have is usually this indicator that is blinking all the time, separating the hours that are on the left hand side and the minutes that are on the right hand side. So the numbers that we have here are in reference to the minutes, and the minutes are in reference to the time after the hour. So what we have is actually 8:45, which means that it is 45 minutes after 8, which we will read on the analog clock to be 15 minutes before 9. When the time is given digitally, the number representing the minutes is in reference to the time after the hour, as we said before. So the clock shows 5:20, which is another way of telling the same time shown on the clock. So which of the options that we have here is another way of telling the time that is shown on the clock? Which one is it, Jerry?
Option D.
Oh, so 20 minutes past 5. Let us see why it has to be 20 minutes past 5. The hour is 5 and the minute is
20.
The 20 minutes that we have there tell us the time after the hour of 5. The time is therefore 20 minutes after 5. When telling the time, the words after and past are used interchangeably. That means if we say 20 minutes after 5, it is exactly the same time as saying 20 minutes past 5. Also, the minutes that we have on a digital display tells us the number of minutes after the hour. So the hour is 5 and we have 20 minutes. That will be 20 minutes after 5, which we know to also be 20 minutes past 5. And option D is therefore correct. The clock shows 5:20, which is another way of telling the same time shown on the clock. The time that is given digitally and the time on the circular clock are the same, and the circular clock is more appropriately called an analog clock. One is digital and the other is analog, and they are saying the same time. The minutes that are given digitally are after the hour. We will count our minutes beginning at the 0 position, which is 12. Right, so we will begin at the 0 position, which is 12. Count the minutes until we get to that minute hand.
5, 10, 15, 20.
Yes, surely it's 20. 20 minutes. 20 minutes. The number of minutes that we have causes the minute hand to be on the past or after side. So the number of minutes that we have indicated by the minute hand of the clock, 20, and the minute hand is on the after or past side of the clock. This confirms that the time is actually 20 minutes past 5, which is option D. Which is usually measured in centimeters? Which is usually measured in centimeters? Right. Which one is usually measured in centimeters?
Height.
Height. Centimeter is a unit of length. Which one in the option is a quantity of length? Which one in the option is a quantity of length? Which one?
Height.
Height is a quantity of length. Height. In the options, height is the only quantity of length. It is the only one that may be measured in centimeters. Option B is therefore correct. Only height is a quantity of length. On the ruler that we have, the unit on the upper edge is millimeter and the lower edge has
Centimeters.
right, centimeters. Heat cannot be measured directly. However, heat is somehow related to temperature. Temperature may be easily measured by a thermometer. So there's your thermometer. And a thermometer is used to measure
Heat. Temperature.
right. So the thermometer is used to measure temperature. And the temperature is related to how hot, right? Heat, how hot or cold something is. Later, you will learn what heat and temperature really are. For now, temperature tells how hot or cold something is. So later on, we will take a look at what heat and temperature really are. When we mean later on, we don't mean on this video presentation, but when you are studying in school. Maybe when you get to high school, you will get a very good understanding of what heat really means. So the thermometer is not used to measure the amount of heat, but the temperature of something. The volume is the amount of space that is occupied. Some laboratory instruments that are used to measure volume are beakers and measuring cylinders. And they are used to measure, what are they used to measure?
Volume.
Right, they are used to measure volume. And the volume will tell us the amount of space that something occupies. In this case, the volume of a liquid may be measured by making use of the scale that is on the side of the measuring cylinder or the scale that is on the side of the
Beaker.
right. So we have liquid going up into the container like that. And there is your scale. And we will use your scale to determine the volume of the liquid that is in the measuring cylinder. Weight is very easily measured, but its unit is not grams, kilograms, etc. And you imagine, as soon as somebody says, let me weigh something, the person will say that we are finding the number of kilograms, so we will say kilogram. How much does this weigh? 5 kilograms. That is not a correct answer, because the unit of weight is not kilogram and it is not gram. It is not any of those units of mass. Kilogram, gram, and so on, milligram, those are units of mass. Weight is very easily measured, but its unit is not grams, kilograms, etc. Those are units of mass. The mass tells us the number of very small particles that something is made up of. The weight of a body is the force by which gravity pulls on the body. So, mass tells us the number of very small particles that it is made up of, and weight tells us the force by which gravity pulls on the object. Because of the close relationship between weight and mass, although mass cannot be easily measured directly, it can be easily found, because there is a close relationship between weight and mass. An instrument that is used to measure mass is actually measuring weight. And the close relationship between mass and weight is used to arrive at the value of the mass. Therefore, any instrument that is used to measure weight may also be used to measure mass. And that difference between mass and weight has to be understood, and it has to be understood very quickly, because mass is the number of particles that are in a body, and the weight of the body is the force by which gravity pulls on that body. And there we have some instruments that may be used to measure mass, and they also may be used to measure weight. The instruments may be used to measure weight and hence be used to measure mass. The one that we have here is our basic balance. The one that we have here is a beam balance. And the one that we have over here is
String balance.
right, it's a spring balance. And some individuals may want to call this a scale, but we know better. The scale is the portion of it that has the marks and the numbers by which the mass or weight is indicated. That is, the value of the mass or weight is indicated. So the scale is what we have right here. Those marks in this diagram, it would be very difficult for the numbers to be placed there, but we know that a scale is accompanied by numbers so that we can tell quite easily the value of the mass or weight that is placed on that balance. Which would you use a thermometer to measure? Is it daily temperature, length of a book, time of day, weight of a body? Which one would you use a thermometer to measure?
Daily temperature.
Right. A thermometer is used to measure daily temperature. A thermometer is used to measure temperature, which gives an idea of how hot or cold something is. The correct answer is option A. And there we have your thermometer. For greater details of the discussion on the thermometer, we may take a look at other volumes of the grade 4 numeracy, and those may be volumes 1, 3, or 4. The length of a book may be measured by a ruler. Regular classroom and laboratory items may be measured by using a ruler also. And there's your ruler. Time may be measured by using a clock. A clock may be digital or analog. The analog clock is usually, but not always, round. It is the one with the hands. The digital clock just has digits. So we have our two clocks right there. The digital one is the one with the digits, just digits alone. And the analog clock is the one that is usually circular, but is not always circular. And it is the one that usually has the hands. Yes, our analog clock usually has hands. Mass and weight are not the same, but any instrument that may be used to measure mass, a similar one may be used to measure weight. And we have them right there, your spring balance, your basic balance, and your beam balance. What temperature is 8 degrees cooler than 30 degrees Celsius? What temperature is 8 degrees cooler than 30 degrees Celsius? What do we mean by cooler? Let us take a look. 8 degrees cooler. On a thermometer, the larger numbers represent warmer temperatures, and the smaller numbers represent cooler temperatures. So the higher we go in temperature, that means the hotter it gets, the larger the numbers that are used to measure or to indicate the temperature. So the hotter temperature are associated with the larger numbers, and the cooler temperatures are associated with the smaller numbers. 8 degrees cooler means 8 degrees less. Which is hotter? The one that is 8 degrees cooler or the one that is 30 degrees?
30 degrees. 8 degrees.
Right, 8 degrees cooler. 8 degrees cooler means 8 degrees less. The number representing the cooler temperature must be less than 30. We will subtract 8 from 30 because cooler means that the temperature is less. So to get a smaller temperature, what will we do?
Subtract.
We will subtract because cooler means smaller in the value representing the temperature. 30 minus 8. We cannot take 8 from 0. We want to say 30 minus 8. 8 from 0. We cannot take 8 from 0, so we go to the greater place value and rename 3. Renaming 3, we will take 1 unit from here we will take 1 unit from here, leaving 2, and the other one will be placed in the present place value position. And we know that the present place value is smaller than the place value to the left. As a matter of fact, the place value to the left is always 10 times the present place value. Therefore, if we take 1 from the left and bring it to the present, it will be 10 of what we have here. So we have 10 and we had there 0. So we add the 0 to the 10 and the result is 10. And we write that by putting a small 1 here and a 0. So it is 1, 0, and we intend that it may be read as 10. 10 minus 8 is equal to
2.
2. And do we have anything to take away from this 2, Jerry?
No.
What will we do then?
Bring down the 2.
Okay, so the 2 will be taken to the place value where it belongs, right there. And the final answer is 22 degrees Celsius. The correct answer is 22 degrees Celsius, and this is represented by option
B.
B. We could magnify the scale of a thermometer and use it as follows. So instead of doing a physical subtraction, we may take a look at the scale of a thermometer. There we have it. Go to 30 degrees. The temperature is 8 degrees cooler than 30 degrees Celsius. So we will begin at 30 degrees Celsius. So we will go to the 30 degrees marker. Right there. The 30 degrees marker is right there. We need to go cooler by how many degrees, Jerry?
8.
8 degrees. This means that we need to decrease the temperature by 8 degrees. The final answer will be larger or smaller.
Smaller.
It will be smaller. Using our pointer, let us step by 8 degrees, getting cooler each time. The number representing the temperature will get less. Will we be going up or down, Jerry?
Down.
Right, so the number representing the temperature will get less. So let us go. Step by 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. We have what? 22 degrees Celsius. So let us do that. We are at 30 and 8 degrees cooler.
2, 3, 4, 5, 6, 7, 8.
Right. Again, we end at 22 degrees Celsius. This confirms our answer as option
B.
Option B. While this method is valid for all similar cases, it might not be time efficient in an examination. However, it may be used for practical illustration or demonstration. Which is likely to be able to contain a maximum of 5 milliliters of liquid? We have some details in this particular problem that we need to pay special attention to. However, we will not try to do it all at once, but by the time we are through with the presentation of this solution, then I think that we would have covered every single one of them. 5 milliliters, Jerry, milliliters. Which one do we imagine will have a maximum of 5 milliliters?
A spoon, a small spoon.
Right, a small spoon. And let us see how we might arrive at that, because it is for us to understand what 5 milliliters will be like. And some students will say, how on earth can we know what 5 milliliters look like? But there's a way to figure out what 5 milliliters will be like. Our main focus will be on the 5 milliliters. Let us attempt to understand what 5 milliliters of liquid looks like. What 5 milliliters look like. Bottle of soda. I am sure, Jerry, that you know what a bottle of soda looks like.
Yes.
Correct. Right. And that bottle of soda is
500 milliliters.
right. So a regular bottle of soda is something that we are quite familiar with. That bottle of soda has a volume of approximately 500 milliliters. So that bottle of soda has a volume of approximately 500 milliliters. There we go. 500 milliliters. Or a bottle of soda, 500 milliliters. So let us compare it with a volume of 5 milliliters. We have 500 milliliters, 5 milliliters. One is how many times the other, Jerry?
100.
It is very clear that what we have here, 500 and just 5. So one is 100 times the other.
Yes.
So 5 times 100 is equal to 500. 5 times 100 is equal to 500. By the calculation that we have there, a soda bottle can hold 100 times the volume of 5 milliliters. Right. So a soda bottle can hold 500 times the volume of 5 milliliters. Which one is so small that its capacity will hold into a soda bottle 100 times? Which one, Jerry, is so small that it takes 100 of them to bring a soda bottle to its capacity? Which one is so small? It must be the
Spoon.
right, it must be the spoon. Only the spoon can be so small that a soda bottle can hold 100 of them. A small spoon. Now we are making reference, making a comparison, and we are using a soda bottle as our item of reference. We are quite familiar with the soda bottle. So if we are using something as our item of reference, it must be something with which we are quite familiar. Surely we are quite familiar with a soda bottle. There's no difficulty in that. But we know that a soda bottle is approximately 500 milliliter. Therefore, if that 500 milliliter is compared with the 5 milliliter that we have in the statement of the problem, that 500 milliliter is 100 times the 5 milliliters. So if the soda bottle is 500 milliliter, it will be able to hold 5 milliliters 100 times. So what is it that we have there that is so small that it will hold inside of that soda bottle 100 times? The small spoon, and it is represented by option.
C.
As a matter of fact, the only container that is smaller than the soda bottle is, as a matter of fact, the only container that is smaller than the soda bottle of 500 milliliter is the small spoon. It is the only possible correct answer. So we have a soda bottle, and that is 500 milliliter. We are talking about something with a volume of 5 milliliter, which is smaller than a soda bottle. Because it is smaller than a soda bottle, the item that we are looking for among the option has to be the one that is smaller than a soda bottle. As a matter of fact, the only one there that is smaller than a soda bottle is the small spoon. it is the only possible correct answer. As a matter of fact, it will take many bottles of soda to fill a bucket and many buckets to fill a tank. So we are looking at the relative sizes of the containers that we have there among the options. So we have the smallest one is the small spoon. Then next a bottle of soda, then a bucket, and finally a water tank is the largest. So the smallest one is the small spoon, followed by the bottle of soda, then a bucket, and then a water tank is the largest. So the only one that is smaller than the soda bottle is a small spoon, and it has to be our correct answer. There we have an ordering of the containers from the smallest to the largest. The word maximum cannot be ignored. The word maximum in the question is also very important. This is because all of the containers can hold 5 milliliters. However, our correct answer should not hold more than 5 milliliters, because we are saying a maximum of 5 milliliters. That means the container that we are talking about should not be able to hold more than 5 milliliters. Because what? All of the containers that we have there will be able to hold 5 milliliters, because it can hold 5 milliliters and more, each one, except the small spoon can hold 5 milliliters or more. So the word maximum tells us that it cannot hold more than 5 milliliters. That means it is very small and will hold 5 milliliters or less. So the word maximum is very important to the interpretation of the problem. The area of the shaded square below is 1 centimeter squared. What is the area of the shape B? The shaded one is what? 1 centimeter squared. And we are to determine the area of the shape that is labeled B. The number of squares will tell us the area of the shaded region, but their borders are not visible, Jerry. We cannot see their borders. So how many squares do you think we have there, Jerry, in the shaded region?
10 centimeters square.
Okay, so Jerry is saying that we have 10 of those squares. Jerry is saying that we have 10. Let's see. We will therefore count them using the visible squares as a guide. Remember now that we just have the area B, and it is in such a way that we do not see the individual squares that we have here, but we have to determine a way to count them. So we will use the visible squares as a guide. By the time I say that, the squares are going all over the place. So let us begin again. 1, 2, 3, 4. Those 4. And then we will have another 4 going up all the way to 8. And then only 2 left. Right, so we have 1, 2, 3, 4. 5, 6, 7, 8. And then we have 9, 10. We therefore have 10 squares, each 1 centimeter squared in area. The correct answer is option D. Take note of the area of each square, which is 1 centimeter squared. And how many of them do we have?
10.
There are 10 of them. And of usually means that we
Multiply.
So we will take the area of 1 centimeter squared, which is represented by one square, one little square, and we will multiply that by
10.
because they are
10 little squares.
because there are 10 little squares, or we may say there are 10 of them. Any number multiplied by 1 is that same number, so 10 multiplied by 1 is equal to 10. So the area is 10 centimeters squared. Or we may read it as 10 square centimeters. Which diagram represents a ray? Which diagram represents a ray? In the diagram, options A to C are related to a straight line. In the diagram of a straight line, there are arrows at the ends that go in directions away from each other. So options A to C are related to a straight line. In the diagram of a straight line, there are arrows at the ends that go in directions away from each other, like that. Notice that we have that straight, what we call here segment, and then we have arrows at the end, and the arrows are telling us that the line continues indefinitely. So that's a graph or a diagram of a straight line. Those arrows indicate that a line has no end. It continues how? Indefinitely in both directions. Others may say that a line continues to infinity in both directions. Option C is a diagram of a straight line. Option C is the diagram of a straight line. Option D represents a vertex with an indicated angle. The curved line is used to indicate the angle. Look at that curved line, Jerry. That is used to indicate the angle. So what we have there is a vertex with a marked angle in option D, and the curved line is used to indicate the angle. A line segment is a segment or section of a line. A line segment has a definite or fixed length. It therefore means that the length of a line segment may be measured, while the length of a line cannot be measured. A line segment is a portion that is segmented, cut off, or removed from a line. The most notable features of a line segment are its two endpoints. The segment is the region between those 2 points. The points are very important because they show where the segment ends. Although they are important in identifying a line segment, sometimes line segments are not drawn with those enlarged points shown. So there we have our line segment. If we have a portion that is cut off from a straight line and we have it bounded by those large dots representing endpoints at either ends, then we are sure that that represents a line segment. Option A is the one which represents a line segment. Which diagram represents a ray? Option B represents a ray. A ray is like a beam of light when you turn on a flashlight. It is emitted, it emanates, or it emerges from a single point. The direction of the ray is always away from that fixed point. So your ray begins at a fixed point and it goes away from that fixed point. When you turn on a flashlight, the beam goes out from where the bulb is and it goes away from the bulb onto the wall or into the streets or into any direction that you point your flashlight. So that is a diagram of a ray. The diagram of a ray contains a single point and a single arrow. The point shows the beginning of the ray and the arrow shows the direction in which the ray is traveling. The ray continues indefinitely, or some may say to infinity, in the direction of the arrow. A ray therefore does not have a fixed length. Its length cannot be measured. So option B is our ray. Option B is the one which represents our correct answer. That is our ray. A straight line is a collection of points. Therefore, it is not always necessary to show the endpoints of a line segment. A line segment always ends at 2 points, whether or not we indicate them with large dots. So as long as we have a line segment or a line is a collection of points. So if we do not show these large dots, because a line segment is a collection of points, then the diagram is still representing a line segment. Ray. A straight line is a collection of points. Therefore, it is not always necessary to show the beginning point of a ray. A ray always begins at a point, whether or not we indicate it with a large dot. So even if we do not have the large dot at the end, it does not mean that we do not have a beginning point, because the line segment is a collection of dots or points. However, rays and straight line must have their accompanying arrows to show the direction of travel. So if we have a ray and if we have a straight line, those have to be indicated by making use of the arrows. They have to be accompanied by the arrows. And the arrows will show the directions of travel. So your ray and your straight line must have their accompanying arrows to show the directions of travel. The arrows must be there to show that the line continues in both directions and a ray continues in a single direction. Which of the shapes, Jerry, is a quadrilateral? And what does quadri mean?
4.
Right, quadri and lateral means?
Sides.
Right. So quadrilateral, 4 sides. Which figure there or shape is a quadrilateral?
A.
Right. The quadrilateral is in option A because the diagram of option A has how many sides?
4.
Right. A quadrilateral is a polygon with 4 sides. Which of the shapes has 4 sides? 2, 3, 4. For a shape to be a polygon, it must be made up of only straight line segments. Option A is a 4-sided polygon. It is a quadrilateral. So option A is the correct answer. What shape is option B? What shape?
Triangle.
Okay, option B is a triangle. How do we know that it is a triangle?
Because it has 3 sides.
And the word tri means?
3.
Right. So a triangle has 3 angles. But it has 3 angles because it has how many sides?
3.
Right. And where we have the pair of sides meeting, there's an angle. A pair of sides meet here, we have an angle. And a pair of sides meet here, we have another angle. So we have how many angles?
3.
So we have a triangle. 3 sides. So there we have our triangle. Option B is a 3-sided polygon. It is therefore a triangle. What am I numbering there, Jerry? I am numbering the points. It is called point. And we will give other explanation and description that will cause you to understand what that figure is to a greater extent. So what I'm labeling there, I'm labeling the 5 points of a 5-pointed star. And the star that has 5 points, like we have there, is called a pentagram. Because of those 5 vertices, or we may say 5 convex vertices that are usually called 5 points, the figure in option C is called a pentagram. So we have 5 convex vertices, which are the 5 points of the 5-pointed star, and it is called a pentagram. The prefix pen means
5.
okay. For example, the first 5 books of the Bible are known as the Pentateuch. As a polygon, it is actually a decagon because it has 10 sides. But because it has these 5 points, we call it a pentagram. Right, a pentagram. So our 5-pointed star is a pentagram. But because it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, we are sure that it is a decagon. And what do we mean by convex vertices? Those convex vertices are pointing outwards. So they are pointing outside of the enclosed area. This is the enclosed area that we have, and these vertices are pointing outwards. Notice that they are pointing outwards, and that is why they are convex vertices. How many sides does that diagram have, Jerry?
7.
It has 7 sides. 7 sides. It is a 7-sided polygon. The polygon in option D has how many sides? 7 sides. It is called a heptagon. The pronunciation should not be confused with hexagon, which has 6 sides, and hectagon, which has 100 sides. Right. So heptagon has 7 sides. Heptagon has 7 sides. Hexagon has 6 sides. And a hectagon has how many sides, Jerry?
100.
100 sides. We will take a closer look at our pentagram, which is our 5-pointed star, which is also a 10-sided polygon, and therefore may be called a decagon. Decagon. Although a pentagram is a 5-pointed star, it is a polygon with 10 sides. It is a decagon. The prefix dec means 10. For example, decameter, decimeter, and decimal. Of course, the way that it is pronounced, the C is sounded here, is because of the vowel that follows. If the vowel is an A or an O, it is dec. If it is an I or a C, it is des. So it is decameter, decimeter, and decimal. That prefix means 10. And we are taking a look at the sides of the pentagram that we know to have 5 convex vertices. And also we are showing that it has a total of 10 sides. The 5 convex vertices are the 5 points. Convex vertices point outwards, as we discussed before. However, take a look at that. Those are not the convex vertices. Those are the other vertices. And those vertices point inward. So they are pointing inside of the area, and they are therefore known as concave vertices. The pentagram also has 5 concave vertices. Those are the vertices that point inwards. It has 10 vertices in all. It has convex vertices that are called the 5 points of a pentagram. And it has 5 concave vertices that we have just labeled right here. It has 10 vertices in all. As a matter of fact, if the polygon has 10 sides, it will also have 10 vertices. The perimeter of the pentagon is 19 centimeters. It is called a pentagon because it has how many sides, Jerry?
5.
Right. Its perimeter is 9 centimeters. What is the length of the side that is marked X? And the perimeter is what, Jerry? What do we mean by the perimeter?
The perimeter is round.
Right. It's the measurement all the way around the object. So the perimeter will be the measurement all the way around. Our goal is to find the length of the side X, and we have the perimeter already. So the measurement all the way around is already given to us, and it is given to us as 19 centimeters. The perimeter is the measurement all around. It is equal to 19 centimeters. 19 centimeters is equal to the sum of all of the sides. 19 centimeters equal to the sum of all, not sum, all of the sides. So we'll begin there. That one is 2 centimeters. Then we have
4.
And what will we have next?
4.
Right. And finally,
2.
but we need to include the missing side that is called,
X.
it is called X. To simplify the expression, we may add the known values. So instead of keeping those values that we have, we may just add these to give one value. So all of those added together will give us 12. So we have 19 is equal to 12 plus X. Why? Because 2 plus 4 plus 4 plus 2, that's equal to 12. So 19 is 12 plus X. The sum of X and 12 is?
19.
We need to answer the question. What number do we add to 12? And the result is 19. What number?
7.
Okay. The number that we add to 12 and the result is 19 is 7. At this stage, students need to know how to reverse a process. If two numbers are added and the sum is 19, then the other one may be found by subtracting the known value from the sum. And the sum is 19. So if we have two numbers giving a sum, a particular sum, say 15, and we know one to be 7, then if we need to find the other, then we will have to subtract 7 from 15. So in order that we may arrive at our answer, we will have to reverse the addition process. Reversing the addition process means that we need to subtract. And if we do that, we will arrive at our correct answer. So 19 minus 12, and the result is 7, as Jerry said before. And that is represented by
Option B.
option B. We may treat the resulting expression as an equation. We need to find x that is in an addition relationship with 12 on the right hand side. So we have 19 is equal to 12 plus x, and that is an equation that we need to solve in order to find the value of
X.
Find the value of x. Now, in solving the equation, we need to eliminate the 12 from the same side that we have x. So we eliminate the 12, and when we do that, we will just have x on that side. And whatever we have on the other side is what x will be equal to. So if we can manipulate the situation that we have there in order that we may eliminate the 12 from that same side that we have the x, then x is what we have left on that side, and what we have on the other side will be what x is equal to. So our goal is to eliminate that 12 from the right hand side. Finding x by eliminating 12. Find x by eliminating 12. Subtracting 12 from 12 gives 0 and will cause 12 to be eliminated from the right hand side. So 12 is on that right hand side. To eliminate that 12, we subtract 12. 12 will be eliminated. Both sides of an equation must always be balanced. Keep the equation balanced by subtracting 12 from the left hand side also. So we need to find x. Therefore, we need to eliminate anything that is on the same side as x. On the same side as x, we have 12. We need to eliminate 12, therefore. Eliminating 12 means that we need to subtract 12 from that right-hand side. But we have an equation, and we cannot just do something to one side, else it is not going to be balanced. In order to keep the equation balanced, we subtract 12 from the left-hand side also. 19 minus 12 is equal to
7.
And 12 minus 12 is equal to
0.
So on this left-hand side, we have 19 minus 12 will give us 7. And on the right-hand side, the 12 will be eliminated, and we will just have x alone. As a matter of fact, 12 minus 12 is equal to 0. And if we add 0 to x, what will be the result?
X.
Right. So 7 is equal to x. And it is very bad manners for us to leave an equation solved like that. We need to have our solution with what we are attempting to find on the left hand side. It is not good to have the solution of an equation with the answer on the left hand side. Therefore, we will turn the beat around. In which diagram is the dotted line a line of symmetry?
Option C.
Option C. Why do you say that it is a line of symmetry, Jerry?
Because it has two halves.
Because it is the only one that divides the object into two halves. But dividing into two halves, does that make it a line of symmetry?
No.
Right, it does not make it a line of symmetry. The two halves need to be mirror images of each other. However, what we see there, it is that only option C has the dotted line dividing the object into two halves, so it is the only possible correct answer that we have. However, we need to take a very good look at what we mean by a line of symmetry, because being divided into two halves, it is not the only property that a line of symmetry has. Dotted line, a line of symmetry. A line of symmetry is one which divides an object into halves that are mirror images of each other. Notice it will divide the object into halves that are mirror images of each other. If one half of an object is reflected in its line of symmetry, then the other half will be obtained in such a way that we will get the entire object. So if we reflect one half in the line of symmetry, then we will get the other half, and when we put those together, the entire object will be formed. If an object is reflected in a mirror line, it is as if it is flipped over or inverted. Inversion does not mean that it is upside down. In mathematics, something that is flipped over sideways is also inverted. We say that it is laterally inverted. So, what do we notice? One half is flipped to the right side and flipped to the left side, and we have the entire object generated. Do you see that, Jerry?
Yes.
Okay. Notice that when one side of the heart is flipped over, the other side is formed. That is the effect that a mirror line should have on an object, and the line of symmetry on each side of an object. So notice it may form one side and then the other side, and then the entire object is formed. That is the effect that a line of symmetry has on an object, and also the mirror line on each half of an object. A line of symmetry is one which divides an object into halves that are mirror images of each other. We have seen that before. But we are saying that that right side is the object and it is reflected on the left side to give the image. So notice that when we put the object and the image together, we have the entire object being formed, or the entire shape, or the entire figure being formed. One half, and then the other half, and then the entire object is formed. If one half of an object is reflected in its line of symmetry, then the other half will be obtained in such a way that we will get the entire object. A line of symmetry is therefore like a mirror, right? With one half of the figure, whichever one, being the object which is reflected, to give the other half, which is the image. So, a line of symmetry is like a mirror, and we may reflect in that mirror line any half of the object. It does not matter which half. If we do that, then the other half will be generated and the entire object will be formed. If we have one half and the mirror line, when we reflect the half, the other half will be generated and the entire object will be the result. If we have one half and the mirror line, when we reflect that half, the other half will be generated and the entire object will be the result. If we reflect the triangle that we have in the mirror line, we say that the original triangle is laterally inverted or flipped over, like so. The triangle and its image will form an object that is symmetrical about the mirror line. And because if we put the object and its image together, it will be symmetrical about the mirror line. Therefore, the mirror line right there is a line of symmetry. The mirror line is therefore called a line of symmetry. Students are required to be visually familiar with an object and its image relative to a mirror line. As such, they should be able to tell if an object is symmetrical about a particular line. If an object is symmetrical about a particular line, then that line is called a line of symmetry. And what does symmetrical mean? That means each half is a mirror image of the other. In which diagram is the dotted line a line of symmetry? The first thing to identify about a line of symmetry is that it divides the object into two
halves.
Right. So if we have an object that is divided into two halves, quite likely it is the one that contains the line of symmetry. However, that is not necessarily the case that it is a line of symmetry, because the two halves must be mirror images of each other if the line is a line of symmetry. However, if the other options as we have there do not have their objects divided into halves, then we are sure that they do not contain a line of symmetry. So we may eliminate options A, B, and D because the dotted line does not divide them into halves. So first, they will have to be divided into halves. If the two sections cannot be identified as halves, then the dividing line cannot be identified as a line of symmetry. Halves are not just any two sections of an object. Halves must be equal. Which option has the dotted line dividing it into halves? Which option is that?
Option C.
Option C is the only option that contains halves. Only option C has the dotted line dividing the heart into halves. Using the mirror line as a dividing line, let us take one side of option C, flip it around. And when we say flip, we mean laterally invert it and see what happens. So in option C, we know that it is divided into halves, and it is plain to us that the halves are mirror images of each other, but we will take steps to ensure that we demonstrate that the halves are actually what? Mirror images of each other. So do that. We have a beautiful red heart as we have on Valentine's Day. But Jerry does not celebrate Valentine's Day. So let us go again. There we have each side being generated when we laterally invert one half of the heart about the dotted line. When one half is flipped over, which is laterally inverted, the other half is generated, resulting in the entire heart being formed. So because of that, we are sure that the dotted line is a line of symmetry.